Alright, so we've looked at balancing redox reactions in an acidic solution. So let's go ahead and look at how to balance redox reactions in a basic solution. We're going to follow the exact same process as we did for the acids, but we're going to add a hydroxide to the H+, and I'll show you what that does. So the first thing is, let's start by writing our balanced half reactions. So we'll start off with Cl- going on to form ClO3-. So the chlorines are balanced, so we'll have to come back and look at this and balance the oxygens. Let's go ahead and look at the manganese complexes. So we have MnO4- going on to form MnO2. So the manganeses are balanced, so we'll have to come back and look at the oxygens in just a second. So now let's go ahead and try to balance the oxygens. So in the first reaction, we're looking at chlorine, and chlorine's oxidation number is changing from -1 to +5. So this represents oxidation. Whereas for the manganese, we have manganese with a +7 oxidation number going on to manganese with a +4. So this represents reduction. So what we can do here as we look at this is we can go through and balance. So for the first reaction, we have 3 oxygens in the products, but none in the reactants. So we need to add 3 waters. Okay, so now that we've added the 3 waters, we have to balance the hydrogen. So we have to add 6H+ over here. But since it's in a basic solution, we need to neutralize these H+'s with hydroxide. So we'll add 6 OH-, so 6 hydroxides, to both sides. So whenever the hydrogen ion and hydroxide come together, they go on to form water. So this is actually, we can simplify this as 6H2O. And then as we look at this equation, we can say, okay, well, we have 3 waters in the reactants and 6 waters in the products. So we can simplify this. So the 3 H2Os cancel out in the reactants, and we are left with 3 H2Os in the products. So now let's look at our second reaction for the reduction. So we have MnO4- going on to form MnO2. So as we look at this, we can see that there are 4 oxygens in the reactants and only 2 in the products. So we need to add 2 H2Os there. And now we have to balance the hydrogen. So we have to add 4 hydrogen ions over here. But since it's in a basic solution, we'll add 4 hydroxides to both sides. And over here, the 4OH- and 4H+, that combines to form 4H2O. So we can simplify this because the 4H2O will cancel out these 2 H2Os, and we'll be left with 2 over here. Alright, so what we need to do is we need to think about what's the total charge on both sides here. And so then we can figure out how many electrons to add. And then after that, we'll be able to combine the electrons. So as we look at this, we can see that we have a total of 7- in the reactants for this first reaction. And we have a total of 1- in the products. So that means that we need to add 6 electrons to the products. Whereas for our reduction reaction, we have a total of a -1 charge in the reactants, and we have a total of 4-, not 3-. We have a total of 4- in the products. So that means we need to add 3 electrons. So the least common multiple of 6 and 3 is 6. So what we can do is we're going to have to go through and multiply this whole second reaction by 2. So we'll end up with 6 electrons plus 4 H2Os plus 2 MnO4 minus yields 2 MnO2 solid plus 8 OH minus. So we need to compare this reaction with this reaction. And there's going to be a lot of things that cancel out here. So the first thing that cancels out is the 6 electrons. You always have to get your electrons to cancel out. So now let's look at the waters. So we have 4 H2Os here, and we have 3 H2Os in the products. So these 3 waters right here, go away, and this 4 is simplified to a 1. The MnO4 should not cancel out. So now let's look at the hydroxides. We have 6 hydroxides in the reactants, and we have 8 hydroxides in the products. So these 6 cancel out completely, and we're left with 2. So now all we have left to do is to combine these 2 reactions. So we have Cl minus from the reactants in the first reaction, that oxidation reaction, plus from the reactants in the reduction reaction, we have 2 MnO4 minus plus H2O yields. All right, so we have, in the products, we have ClO3 minus plus 2 MnO2 solid plus 2 hydroxides. And what I'll leave it up to you to do is to go through and double check that all of the atoms and the charges balance on both sides. So now, what I'm going to leave you with is I'd like you to try to balance the following reaction in the acidic solution. So why don't you go ahead and pause the video and give it your best try. And then in just a second here, you can resume the video, and then I have the solution for you. All right, so for this example, what you'll see is you end up with some pretty large coefficients, and sometimes that happens. So you can always go back through and double check your work. So this is an acidic solution, so just remember that you're not going through and adding hydroxide to the H+ ion.